Here's something to believe
So
in.
stream is started for those of you that okay. For those of you that don't know, the Discord sound is recorded onto the stream. So watch what you say.
Hmm.
We all get quiet.
Yes, that'd be a very good idea. All right, so I guess I can start at forces. I don't care where. I assume I'll have a couple of days of review stuff. But I mean, it'll just be a quick review of forces. Nothing super like in depth or anything, because for the most part, you should kind of know what you're doing at least a little bit. Let me get my marker.
Just a little bit.
Should we be watching the stream?
If you want to see what I'm writing on the whiteboard, that'd be a good idea.
We have a stream? Okay, master.
We have.
Yes,
Wait,
there
what's
is a
the
Oh
stream.
stream?
man.
Jesus,
Wait,
I sent out all the links to you people like three
it's on.
times.
Okay, it's on Twitch.
Yes.
Let me.
All you gotta do is search for the Odon.
No,
T.
done.
It's all one word.
Mr. O'Donnell's right under albino. Freaking. So stupid.
All right. So forces. I mean, basic concept. I'm gonna assume everybody knows the formula for forces.
Let's assume
Ma.
Jamie doesn't.
So yes, F equals ma. That is the general force thing, but we gotta be careful when we talk about that. We really should have a better idea. It's the sum of the forces is equal to the
Oh no, there's
mass.
an echo.
Yeah, mute the stream.
Hold on.
The stream will be a few seconds off because obviously it's not live stream. So it's like 4 or 5 seconds off. But yeah, you'll mute the stream. So
We're on Twitch, right?
yeah, mute the Twitch stream. That way you don't hear the echo. But then this audio will be saved for later. So when you go to watch the videos, if you do, it'll have the audio still. So what we really should think of it as is the sum of the forces is equal to mass times the acceleration vector. And the reason we do that is because more often than not, we have more than one force going on. So you could have any number of forces like on a free body diagram. Remember, they have to touch the dot. So we can just call this like F1, F2, and then like F3 being down. I don't know. Doesn't really matter. So if I have all three of those forces, you can add them up and figure out which way the acceleration is. Is it up, down, left, right? A combination of those, all kinds of things. It could be in equilibrium, so this case could be the case where it's in equilibrium. That should be a definition you have written down. So can someone remind us what the definition of equilibrium is?
The net forces are balanced.
Okay. Is that the whole definition?
Hold up, I'm looking at my sheet.
Net forces and net torques.
There you go. So our definition of equilibrium, which we should definitely have written down as we go through things. If you don't have them on your sheets, you should definitely be adding them and adding to it as I mentioned things.
How do I mute the chat?
Bottom left, there should be a little sound icon. Just make it to 0.
I think I forgot my Twitch password.
You don't have to log into Twitch.
Maybe that's why I don't.
All you gotta do is just go to the stream. You can do it on the website or the app. Don't matter. Um, So yes, net torques and net forces, when we say are balanced, a little bit better way of saying that is the sum of the net force or the sum of the forces is equal to 0, and the sum of the torques is equal to 0 as well. So in this case, if we have that, anytime we are in equilibrium, we know the sum of the forces is equal to 0. So that means that 0 is equal to mass times acceleration. Since the mass is obviously not 0, then we wouldn't be talking about anything. That means that the acceleration is equal to 0 if we are in equilibrium. So if you're in equilibrium, we do have that being where it's equal to 0 there. Okay, so that's kind of a general basic starter. Now when we have most of our forces and things like that, let's say we don't have a balanced situation. Instead we could have, I don't know, a force of, let's say, 30 newtons at an angle of 20 degrees. And then let's say I have a 40 newton at 30 degrees. That makes this 60 newtons. say 15 degrees. So if you have multiple forces acting on it and we don't know if it's in equilibrium or not, we're just asked to find either the sum of the forces, the net force, the acceleration, et cetera, et cetera. We have to then break those down as a reminder into our components. So when we go to do our sum of our forces, we will do one in both the x and the y direction. So if we have forces in multiple directions, which is most commonly the case, you have to look at those cases separately. So how do I get the x and y components of a force in this kind of given situation?
Sine and cosine.
So we use our trig functions, our sine and cosine, to break down the x's and the y's, et cetera, et cetera. So you make a direction positive, make a direction negative, usually right's positive, so I will use that. So if I just look at it and kind of go around, so for the x, we'll have the 30 cosine 20 plus 40 cosine 30 minus the 60 cosine 15. So that, and then don't forget, whenever we do sum of forces, is always equal to ma. Since we're in the x direction, we want it to be ax. And we do the same thing in the y direction. So pretty straightforward, except for in this case it'll be sines. We do have to be careful and watch our values. The only one that's positive will be the 30 because I'm making up positive. The other ones will both be negative. Minus 60. And again, equals ma, but in this case we're looking at the y's. So we get those values, which I don't know what they are off the top of my head. Let's put it into the calculator. Make sure your calculator is in degree mode if you're using the graphing calculator or a scientific calculator. Alright, so 30 cosine 20 plus 40 cosine 30. Hello, Father.
Hello, Mr. Don.
You are most definitely not my father.
Does anyone know how to do it on mobile? Because I still can't figure it out.
Does anyone know the name of the account Mr. Don was streaming on?
The Odon.
Oh, I forgot the O.
1D.
Oh,
Here's-
okay, I figured it out now. They kept on popping up Overwatch streamers, and I can tell they're
You don't have a volume button anywhere on your thing on the mobile version? Like a slider?
Not on the app. Maybe if I change the... Hold on. I think I have an idea.
Okay, I don't know, 'cause I don't... I have, or
There we go. That worked.
Okay, I don't know what you did, but okay. But he was
I-
really excited about
Since
that.
we're in a call, my phone differentiates between call audio and media, and the Twitch stream is considered media, so I just turn the media audio down.
Okay, there you go. Okay, so I got 4.876 for the x. So you just do 4.876 equals, let's say the mass is 2 times ax, et cetera, do all that. I mean, I'm not going to take the whole time to do all that. I'm sure you guys can enter stuff in your calculator. But the one thing I will mention is after you get both ax and ay, those are just the components. How do I get the just straight up acceleration vector?
Pythagorean?
That's correct, Mr. Dante. Very good. So remember, if you draw ax and ay, it'll create a like triangle. So this would be ax, this would be ay, and
Where
then
did
your
you get mass
hypotenuse.
from?
I made it up.
Oh, okay.
I just said it has mass of 2 kilograms. So I don't know, whatever it would be. Like I said, I'm not doing the whole problem. It's kind of just a quick review of things. So at that point, if you have your ax after you get your ax and ay, to put them together to get a, you would create a nice little right triangle. So you get ax squared plus ay squared. And that will hold true of any vector components. So as long as you have the x and y components, if you need the overall vector you can put them together through the Pythagorean theorem.
Nice.
Okay. Making sense, hopefully. Everybody's remembering these things. Yes, this is not
It's all coming
new
back.
information, hopefully.
Oh yeah. No, it's
Okay. So clearly it does become more difficult when we start having things such as, let's do a block, and another block. Somebody give me a mass. Go.
80 kilograms.
Somebody give me another mass.
2.
Two,
Six.
two doesn't work. 2 and 80, no.
Ooh, a pulley.
80.
6.
6 versus 80. Are you serious?
86.
I don't know.
You people are terrible. We'll make it 50.
86.
No.
Okay.
Well, we could.
Somebody give me an angle.
20.
See, reasonable
20.
numbers.
25.
I already picked 20.
86.
30.
I already got
I
one.
don't know.
Okay.
I can't
So-
see. Your thing lags.
That's fine. Alright, so just a pulley system. We'll do case 1, no friction. So we'll start out easy, case 1,
Oh, crap.
no friction. Yeah, we can't forget about friction. Case 2,
Yeah, I forgot that exists.
we'll put friction in. So right now we'll work case 1.
All right,
That's a friction.
bruh. If you're nothing, you don't exist.
Okay, so case 1, no friction. We want to ask ourselves something along the lines of what's the acceleration of the blocks, stuff like that kind of thing. So we have a couple of things we need to do. What's the first thing we can do?
Get the net forces.
Before we do that, we got to do something though.
Axes.
Before that, we got to do something.
Change the axis. Axle.
Even before that, we still got to do something.
Oh, what?
Free body diagram.
There you go. First thing you always do with force problems, free body diagram. Free body diagrams do not care about what your axes look like. They only care about the forces acting on them. So we'll call this 1 and this 2. So 1, 2. Kenna, give me a force acting on object 1.
What'd you say? Sorry.
Give me a force acting on object 1.
Which one's object 1?
The
Okay,
one.
normal force. Sorry, it lags. I didn't know which one you named first.
I waited a while.
John's.
Normal force.
Which way is normal force?
It's perpendicular to the ramp thing.
Which would mean give me some directions. Up, down, left, right.
To the left, up.
Okay,
Right.
so yes, that's good. Up and left. Your description was perfect. Like, don't get me wrong. Perpendicular to the ramp is exactly 100% right. I just want to make sure we knew what perpendicular meant. Some people may not have. And we label those as forces. So normal force. Damien, give me another one on box 1.
What?
Give me another force on box 1. We got normal force already. What's another one?
What?
Force
Which way is gravitation force?
down.
Okay, very good. What do I label it?
FG. Are you still asking gaming, or can we just chime in?
That's fine.
Yeah, okay.
So FG, we agree with that? Everybody agree?
Yes.
Okay. Pipskin, give me another force on object 1.
There's the force from the string,
Which is called?
F of T.
Okay.
It's tension, right?
So force of tension, and tension will follow the string.
Oh,
What was it?
that was loud, dude.
Like a mic.
I have Damien at like 30%, bro. So, and if you can't hear people, remember you can right click on them or click on them if you're on the phone and up their volume. But Hitchkin sounds just fine to me. Dante, give me another force on object 1.
Another one on object 1?
Yep.
In case 1.
Yes.
Uh, I don't know.
Because trick question, there are no more.
Okay.
I'm
Why'd you
sorry.
do that, Mr. O'Donnell?
Because you ain't been in class in like 3 weeks, bro.
Yeah,
Or-
Dante. He's giving up.
It's not been like 3 weeks.
Dante playing hooky.
But 3 weeks is
Dante
like.
playing hooky in an online class.
I've been trying to get my computer to work.
Yeah, you're fine, buddy. Give me a force on object 2, though, Dante.
Object force of gravity.
Okay, so which would be?
F sub g, straight
Um,
down.
Okay. I don't think I caught on Alyssa. Alyssa, give me a force.
Sorry. Tension.
Which way is tension?
It's going to, or it's going, it's like, it's like going down.
Tension's going down on box 2?
Or it's pulling up, but it's like, I don't know. I can't explain.
Tension always follows along the string or the rope or whatever. So the rope is up
Yeah.
from box 2, so it'll be the force of tension will be up.
Okay, that makes sense.
Okay. Do we agree with the free body diagrams that are on the board?
Yeah.
Yes. Also, I'm in another room now, so it should be silent there.
Were you like in the living room? I heard every person in your house like.
Just decided to
Okay.
play Rowdy.
So there is a mistake on those free body diagrams.
Free body diagrams.
Is it? I know what it is.
Go ahead.
The FT and should be numbered, right? FT1 and FT2,
That is
because they're not the same tension.
incorrect.
Incorrect. Okay, damn.
I think Buddy had it too. Is it with both or is it just one?
Technically, it is actually with both. I'll give you that since you asked a good question. It is with both. So technically, there's 2 mistakes.
Do we know where
Is it?
like the bottom is?
It's not hitting the ground, so no, it's not. It's not on the ground.
Is it FG?
Well, I mean,
don't know.
like, is gravity in a different direction or is it?
Will gravity ever be in a different direction than down? Oh, I see what you're saying. Which way it's down?
Like,
No, this is no, this is not like an upside down picture. Kenna, what were you saying before Hunter?
The box is glued to the ramp.
Actually.
All right, Kenna, what were you saying, sweetie?
I just said FG. Is it wrong? But I don't think that's right. I'm just stupid. It's okay.
Why would
Is it?
FG be wrong?
Like, okay, so I have this old example we did, and we labeled the FGs 1 and 2, but I don't know if that's.
Why would I label the
That's
FGs 1 and 2?
I don't know.
Oh yeah, it has to be different because they're different masses.
Dang, Dante, you got really excited about that, bro.
I watched you.
Is that correct?
It is.
I really hope it's not wrong.
It is correct, sir. So we do need to label the gravities.
Yeah, that was close. I got it.
So yes, you were correct, man.
Oh wait, is it just
So-
I'm excited enough.
So why do I need to label the FGs?
Because the forces are different. It's two different.
Correct. So Dante was real close on it earlier with the force of tensions. However, since this is one single string, that string will have the same tension all the way throughout. So I don't need to do that to the tension forces in this case. However, the gravity forces will be different. So in other cases, we've seen other boxes and other diagrams where we've had like multiple strings and multiple boxes and stuff. Then those tension forces will be different. But if I have one single string, that tension in that single string all the way throughout is the same. So I don't need to differentiate the tension forces. However, as we mentioned, the gravity forces will definitely be different. Okay. So we got our free body diagrams, which is usually the first thing they have you do. Now, as mentioned earlier, we will need to rotate our axes. So as we think about the box number 2, it's easy, up and down, no problem. However, for box 1, we need to think about up the ramp and down the ramp. That's the x-axis, and into and out of the ramp, that will be the y-axis. Okay? So if we're trying to find the acceleration of the boxes now, what is my next step? What should I do next?
You trying to find the acceleration?
Yep.
Don't you need the
Have you already
forces
drawn
for
your
that?
axes?
I'm not going to actually draw the axes on there.
Yeah.
Are you gonna flatten it out?
Yes, there you go, Mr. Dante. Good job. Remember that. Don't forget, anytime we have boxes connected like this, we always want to draw a flattened out version of what's going on. So when we do that, we have our 80 kilogram block, our 50 kilogram block. If I think about the 80 kilogram block and I think about which way is the force pulling it, well, gravity is obviously pulling it down the ramp. So as I go to flatten it out and bring it flat, down the ramp will be left. We have the tension force connecting them, which we don't really need. And then the 50 kilogram block, the block that it's trying to be moved as gravity is down. As I go to flatten it out, that becomes to the right. So 1 would be pulling to the left, 2 will be pulling to the right in my flattened out situation. Hopefully everybody remembers doing that, yes?
Right.
Okay, and then I actually squish the boxes together to form one big block of 130 kilograms with FG2 to the left. Oh, careful, I almost forgot, that's FG1X. And FG1X to the left. Careful on that 80 kilogram blocks, we only use the X component because remember, since it's on an inclined plane, it's not the full force of gravity pulling it down, it's only the X component pulling it down the inclined plane.
Got it.
So we can't forget that. At this point now we need to figure out what FG2 and FG1X is. So this is the part you should remember hopefully. So FG1X is mg sine theta. So in our case it'll be 80 times 10 times sine of 20. And FG2 is really easy. That's just 500 because it has nothing stopping it. So it's just 50 times 10. So 80, it's going to be about 400-ish. What is it? So 800. Not into Discord, into the calculator. So 800. Sine of 20. I get, I even lost that. So 273.6 for that.
Hey.
So this is 273.6, and then this is 500. So clearly the sum of the forces, as I talk about this, is now 500 minus 273.6, which is equal to mass times the acceleration. And we now have the acceleration of our box. So 500 minus...
And we have mass, so that being
divided by 130. So I get the acceleration to be 1.74. So acceleration is 1.7.
Is that 0.6?
Yeah, it's 0.6.
Okay.
Sorry. Okay. Now, especially in physics with this kind of thing, ask yourself, does this make sense? So does it make sense that the acceleration is 1.74? It's pretty close to 0 compared to things. Well, if you think about the situation, you've got a lighter box over, like just being held over the ground, and you've got a heavier box on the inclined plane. So does it make sense that it's a pretty close tie, and because it's an angled box with the bigger one, it makes sense. It should not be a very big value. It definitely shouldn't be close to gravity, because you would have to have a box just hanging in midair for gravity, so it shouldn't be anywhere close to that. But it should be pretty close to 0, because it's almost in the equilibrium state. Does that make sense for everybody?
Sounds good.
Okay.
yes.
So now,
So, wait,
oh, go ahead.
How did you get from how'd you get the acceleration? 1.74?
I solved the equation at the bottom where 500 minus 273.6 equals 130a. I just did the subtraction on the left and then divided by 130.
Oh yeah. Oh, and you got 130 from
The mass,
two.
because it's them
Okay,
two combined.
mass. Okay. Squeaky shoe.
Okay, any other questions on what it did?
And then you got the force of the 50 kilogram box just because the only one acting on it is the gravity.
Well, it's not the only one acting on it, but when we flatten it out, what we're doing by squishing it together is we're ignoring. Remember, the tension's called an internal force. So the only force that's acting on it that's causing motion is the gravitational force. So.
Okay, so then you did that times 10.
Mm-hmm.
And then you used sine theta to get that's the force of gravity.
So on an inclined plane, we can't forget the force of gravity down the plane is the mg sine theta. So that's fg1x.
Okay, okay, I see.
Any other questions? Okay, so now find tension in the string. So how are we going to find the tension in the string?
Don't you like do the thing where you like add different together? I don't even. Oh,
You also might want to change your sensitivity just slightly because you keep cutting out as you talk, Sweeney.
oh, do I?
Yeah, a little bit.
Um,
Go ahead.
like where you add all the forces together or subtract the forces from one another. I forgot what that's called.
Summing up the forces.
Yeah, but yeah, I guess.
So you're not wrong, but you're not 100% right. You got to add a little more to that. Anybody else
I
want
don't
to
know
take
what
a
to
stab
add.
at it?
I'm thinking.
I'm sorry, I got lost. I was eating like cashews.
Did you bring enough for the
Yeah,
whole
get
class
lost
to
in
share?
cashews.
I mean, it's a full case.
I expect my cashews to be delivered, sir, in an unopened
You can
container.
Venmo me those cashews.
Bro, nobody in this house drives except for parents.
I will mail you them like just the cashews in
Almost one day
by
delivery.
Yeah,
themselves.
cashews in an envelope. Okay. So to get our tension force, we do need to sum the forces up, so Alyssa is correct there. However, this is where we go back to just one of the blocks. So we push them together to find the acceleration of the system, because that is a combined thing. They share that. Now when I go back to do tension, this is why we did our free body diagrams to begin with at the very beginning, is so I can analyze them individually if I needed to. So to find the force of tension, I'm going to go back to just one of those. Because I can't use the push together system. The push together system has the tension gotten rid of. So instead we have to look at just one of the individuals. I always suggest using the easier one. Which one's easier? Box 1 or box 2?
Box 2.
Box 2 is way easier because this is gravity and tension. So when I go to sum the forces up, ooh, we have to talk about something in a second. So we didn't talk about the direction of the acceleration. Which way is the direction of the acceleration?
It's down.
Careful.
I mean, south.
South.
Okay. What I mean by being careful is you have two different boxes. Are both boxes going down?
No.
Left.
It's
Down.
So it's left.
it's going
Left
yeah.
down.
So which way is box number 1 going?
It's going diagonally bottom left.
It's going down to the left?
Down and to the left at the same time.
Okay, which way is box 2 going then?
Up.
Up.
Okay, that is not true.
That's not true. Oh wait, no.
You guys have them reversed. Which one is the bigger force, FG2 or
Oh, it said-
FG1?
oh, I
Hold on.
I read that as
2.
2000 for a second.
So
Box 2 is going down.
FG2 is the one that is going to win, so it's going to go down. So our acceleration for box 2 is down, and for box 1 is up and to the right. So we got to be careful. Okay, so always think about the direction. Usually they just ask you for the value because you can't say, oh, it's down for this one, up and to the right for that one. So just asking for the value. But we do need to take that in consideration. So that's why I brought it up. So when I do the sum of the forces for box 2, I only need to do the y direction, which is fine. What would I write for the sum of the forces for box 2?
F. Oh, no.
FG2 minus FG.
I can do that, okay. I mean, there's really not a wrong answer almost. There's only one wrong answer. But so f of g2 equals that.
Plus FT.
That would be the only one that's wrong, is if you added them. Okay, so fg2 minus ft equals?
Oh.
Yeah.
Yeah.
Always, sum of the forces always equals ma. Now, I don't need to put a y in there because it's all in the y, so that's not a big deal. Okay, so no harm, no foul. So we know most of these. We're looking for ft, so that's going to be the only thing we don't know. So we can fill in our fg2, which is 500. The mass of box 2 is 50. What's the acceleration of box 2?
Box 2.
Is it 1.74?
Wait, yeah, it is.
Okay. It is 1.74. Now you have to be careful. Should that 1.74 be positive or negative?
For box 2.
Isn't it negative because it's going down?
That is relative.
Oh, shut up.
I
Father.
watched these.
Well, see, when you tell
Is
him
it
to shut
negative?
up, the unfortunate part is he is exactly correct.
Oh.
Oh, who Dante?
Yes, it is relative and it depends. What did he do by setting up his sum of the forces, because he's the one who did this? When he says fg2 minus ft, what did he do?
I made the bigger one, the first one.
Besides just making the bigger one, the first one, you made
FG.
f of g positive. Which way is f of g?
Down.
Down.
Down. This means down is positive, up is negative. Which way is the acceleration?
You circled like a minute ago.
Oh, so it would be positive because it's going down.
Right. Most of you would have done this up here, which I'm about to do in the left-hand corner. You would have said sum of the forces equals ft minus fg2 equals ma. Okay, no problem. You do ft minus your fg, which is the 500. Right, yeah. Equals 50. But then you would have put 1.74 there. So it'll be on the stream in a second. If you look at the upper left-hand corner, you've actually created yourself a contradiction there. You said f of t was positive, so up is positive, and then you've told me that box 2 has a positive acceleration. It is not a true statement in the upper left-hand corner. This is where you've got to be careful and make sure things agree with each other. So in this case, you need to have a negative on the 1.74, because the acceleration would be in the downward direction. Does everybody see the difference between the two?
Give me like 5 seconds, and then I'll see it.
How far behind is your stream?
Okay, go into the camera and then count down from 5, and then we'll tell you when we see it.
Yeah, because ours is 2. Mine is the exact way Hunter's is.
It's behind quite a bit. It's probably like 6 seconds.
Yeah.
Okay, there 5, 4.
Okay, so you're by about 6 seconds. That's not too bad.
2, 0.
1, 0. Oh, Damien's on that next level lag.
Yes, that's what I'm saying. Like some people
Maybe an extra 2 seconds behind.
Some people are reporting like a 20-second lag, and I'm like, that's...
Bro, mine hasn't even started counting from 5, so...
Wave is 0.
Wait, are you serious, Alyssa?
I'm not kidding.
Like, you haven't...
More been drawn on yet?
Bro, like, you haven't seen me
Here we
counting?
go, now you're counting, now you're counting.
What kind of internet you using, girl?
I mean... I don't know.
What?
Couldn't do it for the glory of the
What?
Netherlands. I don't...
That's... let me pull up the stream on my end and see how far behind I am on my end. Because it should be about 4 or 5 seconds.
Mine's like
It's like-
a
it's like
30-second
that.
lag. Mine's like a 30-second lag, 20-second lag.
Mine is lag. I just saw it,
Mine is
bruh.
No,
Yeah, I'm like
Mine is
a
lag.
yeah, I'm like a 5-second lag.
3, 2, 1. How does Dante have better connection than like everybody else here but me?
Nah, that's about right. I mean,
The guy who hasn't been here for 2 weeks has better internet.
tell me when yours
Been
starts
working on
counting,
both.
Alyssa.
1,
Oh
0.
my god, Chris!
Holy crap!
Wait,
Chris, how are you counting
are you gonna
up?
count
You
again?
counted down.
Hold on, you still haven't?
Yeah.
Please tell me you're joking, Alyssa.
I'm not. I'm literally not.
Is it like this in calculus class for you too?
No.
Chris started
That's weird.
counting down.
I have to like exit out and then exit back in.
Yeah, maybe just like refresh the page or something, because that's really bad. Because I counted like I've been sitting in my chair now for like 10, like at least 15 seconds, and you haven't even started counting yet.
Wow.
No wonder you kept saying it's not on the board. I'm like, yeah, it's been on the board.
Yeah, mine's bad.
Yeah, just refresh the page if it ever, starts to, if it's super far behind what I'm talking about, like it's got to be about 4 or 5 seconds. That I can't help. But the way I have it, have to do the setup, it's
If you want to get better, then maybe you'll
so that's really far behind.
Could just be good.
Anyway, so
Yeah.
upper left, either situation is perfectly fine. Solve for your force of tension. The other hint that you're going to get if you do it in the incorrect order, you will get a force of tension that is bigger than 500. Should the force of tension be more than 500?
No, because it's
No.
going down.
No, because we know and we already figured out that that box is going down. So if you do it the incorrect way and don't do like the sign correct on your acceleration, you'll get a force of tension that's something like 560, 570 in this case. And that should trigger to you that that makes no sense. The force of tension shouldn't be bigger because then the box would be going up if the force of tension is greater than gravity.
Hate the delay.
That's unfortunate, but it's the best way to do it because I don't have a...
Can you stream on Discord?
No, Discord only streams your screen, not your... I need the whiteboard to be able to be shown.
Oh, do you not have a camera?
No, I'm using my phone. My phone.
Your phone on Discord.
You can't do that either.
Decent quality for phone camera.
That's because I have a good phone.
What kind of phone is it?
It's the S10.
Oh yeah. Oh, you just gotta one up it when I get the S9.
Bruh, you're lucky I don't have the S20. Why they skipped 10 numbers, I don't know. I don't know. I don't know why they skipped to the 20. All right.
Just what happened to Xbox 2, 3, 4, 5, and it counts all the way up to 359.
0.1.
No, they went back to Xbox One.
So we'll do.
That's what I said. 2, 3, 4.
Next, Xbox Zero.
No, Xbox Zero was the first one.
Oh, what? Wait, then what?
Yeah, it was just an Xbox.
That's not Xbox Zero.
That's
All right.
Xbox One.
Okay,
Wait.
well,
So,
Xbox Zero.
your homework. Do case 2, but you're involving friction. The numbers are on the board for your coefficients of friction. So mu k is 0.1, mu s is
Do we
0.15.
need to take a screenshot, or is it just
How
going to be
are
on
we
the screen?
turning it in, or is it just going on like that?
We'll go over it tomorrow. I'm not going to make you turn it in, but I expect you to have it done, at least attempted. You can take a picture of it right now if you want to or not. The video will be posted as soon as it'll be up on the YouTube page.
I'll DM you my helicopter.
You have to fly it over.
All right.